Hello, this lesson is going to explain how to find the inverse of a 3 by 3 matrix using the Gauss-Jordan method. Our first step is to determine if an inverse exists, and we do that by calculating the determinant. Then we augment the matrix with the identity matrix and perform some scalar and or row operations to convert the original matrix that will be on the left into the identity, and then the result on the right will be our inverse matrix. So to start with, we'll find the determinant of this matrix. By doing that, we choose a row. In this case, I'm just going to pick the top row. It's nice to have a 0. And the one thing to remember is when you are doing this, there is a pattern that you have to match up. So since I think about the top pattern the easiest, I'm picking that row. If I were to choose the bottom or second row, I would need to change this negative to a positive, and that would be about it. But we're going to do just the top row here just to make it simple, but it'll work on any row you choose. So choosing this top row, I've got a 0, 4 becomes negative because of the need for a minus to this pattern, and then the 1, and then the 1 has the negative 1, negative 3, negative 1, negative 1. So when we do the math here, we don't have to worry about that first value. It's got a 0 to multiply by. The second one will end up with a negative 4 times 0, so that cancels out also, and I'm just left with 1 times the determinant of this these values, and I get 1 minus 3, which is negative 2. And the good news is we have an inverse for this matrix because we did not get a 0. So to find the inverse using Gauss-Jordan, our method is we take our original matrix and we augment it with an identity matrix, something like this. So 1, 0, 0, 0, 1, 0, 0, 0, 1. And now as I do my manipulations, I'll be affecting the right side here, and in the end that will be my inverse. And now I'm going to do some manipulations here. I'm going to move, I'm going to create R1 will equal current R3, and R3 will equal current R1. And that then produces and from here, if I multiply this top row by negative 1, I get okay. And now if I multiply, or sorry, just add R1 to R2 and replace R2, I'll get a 0 here and a 0 in this entire column underneath our original 1. Now we're ready to work on the second row and second column. Our first column has a 1 with zeros underneath. So to get this number to be a negative 1, we multiply, or we replace R2 with a negative 1/2 current R2. And now to get rid of this 4 and get it to be a 0, we will take our 2 and multiply by negative 4, add it to R3, and replace R3 with negative 4 R2 plus R3. And negative 4 times negative half is positive 2. Negative 4 times positive, negative 4 times negative half is positive 2. Negative 4 times positive 1/2, negative 2. And we are almost there. Our goal is to get the elements above the diagonal to be 0 as well. And we already have most of that accomplished. Just need to get rid of this one. So if we replace R1 with a negative 1, R2 added to R1, we'll get 1, 0, 0. And now a negative, so we got a 0 there. Negative 1 times negative half is positive 1/2. Negative 1 times positive 1/2 is negative 1/2. And a negative 2/2, that's a negative 3/2. And now that we have the identity matrix on the left, we have our inverse matrix, the resulting matrix on the right here. And it's very often this matrix looks a bit messy. We're going to go ahead and check it now. So we're going to multiply rows times columns, see if A inverse times A gets us our identity matrix. So 0 times 0, a half times negative 1 is negative 1/2, plus negative 3/2 times negative 1 is plus 3/2. And we can put parentheses to show that's the first row, first column element. I'll work my way across. 0 times 4 plus half times negative 3, negative 3/2, plus negative 3/2 times negative 1, plus 3/2. And then our last column element, 0 plus 0 plus 0. That one's an easy one. 0 times 0 is 0. Negative 1/2 times negative 1 is a positive 1/2, plus 1/2 times negative 1. Second row, second column, 0, negative times negative is positive. 3/2, 1/2 times negative 1, negative 1/2. And then 0, 0, 0. That last column is kind of nice. 1 times 0, 0. 2 times negative 1 is negative 2. Negative 2 times negative 1 is positive 2. 4. 2 times negative 3 is minus 6. Negative 2 times negative 1 plus 2. And then 1 times 1, and then a bunch of zeros. So if we simplify this and take a look at our matrix, negative 1/2 plus 3/2 is a 1. Negative 3/2 plus 3/2 is 0 and 0. Negative 1/2 minus 1/2, 0. 3/2 take away 1/2 is 2/2, or 1, 0. 0. 4 minus 6, negative 2 plus 2, 0, 1. Sure enough, I'm going to say that that is our inverse matrix by the Gauss-Jordan method. Thank you, and we'll follow up in class.